Hello and welcome to the 2x03 2G03 tutorial for conditional input demands. This is the last one I'm making today. I actually made the first 6 or 7 today, so my voice is getting tired. I'm going to hang up my microphone. This one's for conditional input demands. I remember asking you to save the production functions from the last one, but then it occurred to me that I could just write them down again, so if you did that, then congratulations, you're a good listener, but you wasted your time. So the first one is what are Marcia's CIDs? The second one is what are Ralph's CIDs? The third one are what are the CIDs of a firm with production function y equals z1 power 1/8 times z2 power 1/2, where w1 equals w2. So if you would go ahead and pause the video, attempt to solve those 3 problems. I will flash the answers and we will go through the solutions, and hopefully I can get this done under the allowable time. Okay, so here are the answers, and I'm going to get you to pause these and check them because actually I guess if you pause them then you can't see the problem. Interesting. That never occurred to me until now. So anyways, I'm going to leave these up for a second then. And then we're going to go through and do the first one. Okay, so the first one is the minimum function. This is the easiest one I've noted here on the side. You've got the simultaneous equality solution method, and what that is fancy way of saying is that C equals 1 over 3 Zm and C equals 8 Zt at the same time. So what that means is if I actually draw out this production function with little emphasis on quality because I can't do it, just realize that these are all straight lines and that they curve at 90 degrees at these points here, which are the cost minimizing points because it gives us quantities at which there's no excess of anything. So if you had an excess of something, since nothing's free, then you're paying for it, so your cost is higher than it need be for a given isoquant, which are these little L's here. Okay, so to be on the corner, right, then for this function, C has to equal 1/3 Zm, and C has to equal 8 Zt. Okay, so if you know that, then it's pretty straightforward to find that Zm star is 3C, and Zt star is 1 over 8 C. Okay, so this is basically a conditional input demand, because what a conditional input demand tells me is that if you tell me an amount of output, I can tell you the cost minimizing amount of each input to buy with one function, right? So if you tell me that you want 7 chilies, I'll tell you to buy 7/8 of a unit of tea and 21 units of mystery meat, right? So that's how a conditional input demand works. For my students who are in Professor Bruce's class, if you give me one of 2 conditional input demands and you give me that Zm equals some function of Zt, I don't care about that. That's not what I want. You will be docked marks. So the next one is Ralph's problem, and of course with perfect substitutes, my first note applies. You use only one input, and that there's price conditions on a conditional input demand. Okay, so if you were stopped on the answers and you saw that big long thing, that's the answer to this one, and that's why this one's a little bit harder. Okay, so for starters, I want to set each individual element of this equation equal to p, just like I did before. So p is going to equal 2 ZV. P is going to equal ZG, and P is going to equal 1/2 ZL. Okay, now why have I done this? Okay, I'm only using one input, right? But there's a price condition on the conditional input demand. So I'm going to use whatever input gives me the cheapest way of producing the output. Okay, so to do that, I need to look at these ratios that give me 1 unit of P to compare what the prices would have to be for me to want to switch, right? Okay, so I want to compare at p equals 1. Okay, so I'm setting p equals to 1 for each of these things. Okay, so I'm just going to do the first example. Actually, you know what? I'm probably not that stressed for time. I'm not going to do just the first example. I'll do all the examples. So 1 equals 2zv, zv equals 1/2. Okay, 1 equals zg. So it's really, I'm just going to write this again, but it's not really any different. And then 1 equals 1 over 2 ZL. ZL equals 2. Okay, so these are my quantities of each that will give me 1 unit of output. Okay, so how much is my price for 1 unit of output using each of these inputs? Well, cost, right, TC, this isn't the chili from before, right, equals price times quantity, abstracting from fixed costs for this very simple example. Okay, so maybe I should just get rid of TC, although I was using it to separate myself from chili. So the cost equals the price times the quantity. Okay, well I know the quantity is 1/2. Okay, so then my cost for 1 unit must be, and I'm going to use WV to represent the price of vegetables, times 1 over 2. Similarly, my cost here is going to be P times Q. Q is now 1. So my cost here is going to be WG. Again here, ZL equals 2. Yes, so cost equals price times quantity equals W lobster times 2. Okay, so now I want to think, okay, what is my cheapest way of producing this thing? Well, okay, if 1/2 WV is the cheapest way to produce it, then it must be less than WG. Okay, and 1/2 WV then must also be less than 2 times WL, right? If it's going to be the cheapest way to produce 1 unit, then it has to be less than this C, which I'll label CL, and it also has to be less than CG. Okay, so this is if CV lowest. Okay, now I can tell a similar story for CG and CL, and they're going to look similar. So if CL lowest, right, then 2WL has to be less than WG, and 2WL has to be less than 1/2 WV. And then if CG is the lowest, then WG has to be less than 1/2 WV, and WG has to be less than 2WL. Okay, so notice I'm not saying anything about the relationship of WG to WV in this one, or WG to WL in this one, just that WV has to be less than both of them to produce 1 unit. Okay, so these are my conditions for using a given input, right? So if CV is the lowest, then I'm going to use vegetables only. So if I'm using vegetables only, right, then P equals 2ZV. So ZV star must equal 1 over 2 P, right? And then I have to put if 1/2 WV is less than WG, and 1/2 WV is less than 2 WL. Okay? And then what if it's not, right? What if that's not true? then CV, the cost of the producing with vegetables, is not the cheapest way to do it. So I'm not going to produce with vegetables. So it's going to be 0 otherwise. Okay. And I also then, what if gators are the cheapest way to do it, right? Well, then P equals ZG, right? So ZG star, and I'm sure you can see where this is going. If WG less than 1/2 WV and WG is less than 2 WL. And of course, if it's not the cheapest way to do it, then 0 otherwise. Okay, and last but not least, P equals 1/2 ZL, right? So ZL equals 2P if 2WL is less than 1/2 WV and 2WL is less than WG, and of course 0 otherwise. Now you're thinking probably, well, what if all of these are the same thing? Well, that's a good point. You can pick one of the options and make them weak inequalities, so that if that is the case, then you're still producing something. That's not necessary for this course. That's a mathematical completeness that you can abstract from without penalty. So, because that's probably not going to happen in the real world, right? So you're not going to get 2 lobster tails for less than the price of a ½ pound of veggies. So we can abstract from that fairly safely. So lastly is the diminishing MRTS problem, which is, as you can see here, the most work and that you need to practice because they're not easy. I've seen people stumble on these on the quizzes that I grade all the time, and that makes it more frustrating for me to grade. So for the better you do, the better I do, and everybody's happy. Okay, so we started off with this production function and the knowledge that the price of both inputs was equal. Okay, so I'm going to dig up my answers here. So I've taken the liberty of taking the partial derivatives already, which you should know how to do. You should remember from class, right? I take the partial derivative with respect to Z1, take the partial derivative with respect to Z2, and divide the first by the second to get my MRTS. Okay, now I've stopped there. So far I've done step 1, take partial derivatives, and step 2, find MRTS. Okay. Now I can simplify this MRTS, which is going to make it way easier for me to work with. Okay, so I know that dividing by a fraction means I'm going to flip the fractions and multiply. Okay, so I'm going to multiply this by 2 Z2 to the 1/2 over Z1. This should be 7/8 here. Okay, Z1 to the 1/8. Wondering why that wasn't working yet. Okay, so since I've done that, I'm going to go ahead and erase all this because this is equivalent. Okay, now I can simplify this, right? Remember, I have like bases. I can add the exponents. 1/2 plus 1/2 just equals 1. And again on the bottom, like bases, Z1 to the 7/8. I know that's probably not that legible. Times Z1 to the 1/8, and that's going to give me 8 Z1. Which I can then simplify to 1/4, so I'll go ahead and do that. Okay? Now with that knowledge, set 2, which refers to MRTS, equal to the price ratio. Okay, so what is the price ratio? Well, over W2, right? So the price ratio, the ratio of the price 1 to price 2. Well, I said those were equal, Okay, so if a fraction has the same numerator as denominator, then it just equals 1. Okay, so then I'm solving for AZ. Okay, so let's solve this, right? I'll cross multiply so that Z2 equals 4 Z1. Okay, so now I'm going to plug 4, which this would be 4 if I was keeping track of my steps, into the production function, which is y equals Z1 to the 1/8, Z2 to the 1/2. Okay, so let's do that. Y equals Z1 to the 1/8. And then instead of Z2, I'm going to write 4Z1 because that's the same thing. And remember that those are both raised to the same exponent, right? So I can't just put the 4 times Z1 to the 1/2. That doesn't work, okay? But what I can do is I can take this 4 out of here by taking the square root of it. That becomes 2. I have Z1 to the 1/8, Z1 to the 1/2, and those are multiplied. And I'm sorry if that 1's confused with that 1/8. Just going to have to deal with it. Okay, so now I've got two like bases multiplied together. I can add the exponents. That's going to give me that y equals 2 Z1 to the 5/8. Okay. Now it says up here, solve number 6, solve for z. That gives you conditional input demand number 1. Okay, so go over here, and I will say that then y/2 equals Z1 to the 5/8. All right, so then Z1 star, which is my conditional input demand, right, must be y/2 to the power 8/5. All right. Okay, well, lastly, I'm going to plug this Z1 into 4, this equality over here, to give me my conditional input demand for Z2. Because remember, I want the Z's only as a function of y. So I know that from 4, Z2 equals 4Z1. So Z2 star equals 4Z1 star. Then Z2 star equals 4 times y/2 to the 8/5. Okay, and there's your conditional input demand. So if you can remember these steps, or you can remember how to do the problem, you will succeed at this problem on the test. And that is all I have for you for this tutorial. And I will see you with whatever I come up with for next day.